S. Chand presents Educational Video Lectures as per the new UGC curriculum. Difficult concepts made easy. Study anywhere, anytime.
In this video, we will be learning about the maximization type assignment problem. And the maximization type assignment problem is somewhat confusing for the students because assignment problems or allocation problems are particularly related to minimization type objective. But in some of the situations, we have an objective in which we need to maximize certain aspects for allocations. Let's say if we want to allocate subjects to different set of faculty members in a particular university. So for that, we need to look for the feedbacks, that is the previous data that is there when the faculty taught that particular courses in the previous semester or the previous years. And the head of the department has to allocate the subjects to the different faculty members in a view to maximize that feedback value. So the objective here is not to minimize, but the objective is to maximize the total objective, the total objective function. So we'll be looking at the maximization type assignment problems in this particular video.
If you want to study this topic in detail, refer to these books from S. Chand Publishing and Vikas Publishing House. Link is provided in the description box.
Welcome to S. Chand Academy, and I am Anmol Bhatia, and we'll be doing the course Business Mathematics. So the topic for today is maximization type assignment problem. The course that we are doing is Business Mathematics, and it is a part of the module which is linear programming problems. So majority of the books says that we have different procedure for minimization type assignment problem, and we have a different procedure for a maximization type assignment problem. So what we will do, we will try to correlate the minimization type assignment problem with the maximization type assignment problem so that the steps to remember would not be different. If we remember one particular step, then we will do the type 2 problems with the help of those similar steps only. So what is the procedure we will be following to solve this maximization type assignment problem? One is we will be converting the maximization type assignment problem into the minimization type assignment problem by following certain steps. Now, when we got this minimization type assignment problem, then the number of steps are similar, like we will do the row minimization and the column minimization, and then we will try to allocate the zeros in boxes, and we will be following that Hungarian algorithm that we have seen in the previous part of the video related to assignment problems. If you haven't watched that video, you can visit the playlist of this subject which is there in the S. Chand Academy channel. So we will be straight away coming to an example in which we will be solving the maximization type assignment problem. Here there are some persons which are, let's say, some machines which are M1, M2, M3 and M4, and we have certain persons which are connected to them, and we want to allocate the task to the particular persons with an objective to increase or with an objective to maximize the overall outputs. So what we will do, we'll follow a procedure, and that procedure is conversion of maximization type problem into the minimization type problem. So first step is to convert the maximization type assignment problem into the minimization type assignment problem. So here you will look for the maximum number from all the elements. So here in totality, the maximum element here is 28. There is no other element which is more than 28. So what we will do, we will subtract all the elements from 28. So by doing so, we will convert maximization type problem into a minimization type problem. That means 28 minus 5, 28 minus 8, 28 minus 12, 28 minus 2 will get a number, and that particular number is to be written correspondingly to the first row. In the next row, we will do 28 minus 17, 28 minus 28, 28 minus 16 and 28 minus 1. We will get these numbers. So, for the third row, what we have to do, we need to subtract 28 from all the elements. So, 28 minus 20, 28 minus 22, 28 minus 3, 28 minus 5. We will get some numbers, and again for the last case, we will have these numbers. Now, what we have done, we have converted the maximization type problem into the minimization type problem. That means we have got the case in which we will go with the row minimization and the column minimization aspect. So, after this, the procedure is similar as the case of Hungarian algorithm. The procedure is row minimization and the column minimization. We will look for the minimum number in the first row, and the minimum number is 16. So, we will subtract 16 from all the elements. We will get the numbers. That means we will get 1 0 in the particular row. In the next row, we already have 0. So, 0 is to be subtracted. So, 0 is there. And in the next row, we have the minimum number, which is 6. So, 6 needs to be subtracted, which is already there. So, 8 minus 6, 6 minus 6, 25 minus 6, 23 minus 6, which is these numbers. And in the next row, we have this 18. So, 18 is to be subtracted from all the elements. We will get certain numbers. Now, then we will go with the column minimization. So, for the column minimization, we will look for the minimum element in a particular column. So, the minimum element in the particular column is 2. So, 2 is to be subtracted from all the elements, and it is to be written over here. In the next column, 0 is already there. So, we subtract 0 from all the elements, we will get the same numbers. In the next, we already have 0. So, 0 is to be subtracted from all the elements, we will get the same third column. In the fourth, we are having the numbers in which the minimum part is 1. So, we need to subtract 1 from all these elements, we will get these numbers, which is 10 minus 1, 27 minus 1, 17 minus 1 and 1 minus 1, which is 0. So, we got a reduced matrix, and we have to make sure that this reduced matrix is a non-zero reduced matrix. That means all the elements in this particular matrix should be non-negative. All the elements should be positive. Now, what is to be done with all the elements? So, Hungarian algorithm is the case, and we have to move from top to bottom and left to right in order to allocate that particular job to the particular person. So, when we are moving from top to bottom, we will look for 0. So, here you can see that we have a single 0. So, we will be allocating that single 0. After allocating the single 0, we will look for the particular column. If that particular column is having any other 0, so we need to cross it up. For the second row, you can see that we have a single 0. So, we will allocate that single 0 and try to cross the other zeros which is there in the particular column. In the third row, you are having 2 zeros because this 0 is already there and this 0 is crossed. So, we are not sure. So, we need to skip this particular row. In the next fourth row, you are having 2 different zeros. So, what we will do, we need to skip this also. Then we will go with the left to right aspect. So, top to bottom is done, and then we will go with the left to right concept. So, from left to right movement, we will look for the first row, and in that first row, we are having 1 0. So, we will allocate that particular 0, and if that particular column which is allocated is having any other 0 in the row, we need to cross it up. In the second column, you are having a 0 that is already allocated. In the third column, there is a 0 that is already allocated. In the fourth column, you have to look for an allocation. There is a single 0 there, so we need to allocate that 0 here. That means all the allocations are done now. You were having 4 persons and 4 different jobs were there. So, whenever you want to allocate that particular job to the particular person, you have to look for all these allocations, and all these allocations should be done. So, when all these allocations are done, you are done with it, and you need to just connect the persons with the same. So M1 is connected to P3, it's written over here. M2 is connected to P2, M3 is connected to P1, and M4 is connected to P4. And then look for the elements or look for the associated data from the initial value, which is of the maximization type. So when you total it up, you will get a maximum value in hand. We stop here for a short break, and after coming back from the break, we will look for more complex problem which is related to maximization type assignment problem.
Now quality learning is easily available at your doorstep. S. Chand Academy brings detailed lectures based on UGC curriculum as per the New Education Policy 2020. So do not forget to subscribe to the S. Chand Academy and access the wide world of knowledge conveniently sitting within the comfort of your home. Stay connected and keep watching S. Chand Academy. Happy learning!
Welcome back to S. Chand Academy after the break. Before going to the break, we have learnt the concept of maximization type assignment problem. Now we will be looking at a particular situation in which we have to iterate this maximization type assignment problem. Straight away we are having this problem, and this problem says that there are 4 persons and 4 jobs are there, and we need to maximize the output. So our output may be the efficiency, or output may be the productivity. So productivity needs to be enhanced, or we need to increase that particular productivity. Although we have seen a procedure in which assignment problem is applicable to the minimization type situations, but we will be linking that minimization concept with a maximization concept by doing what? By converting this maximization type table into the minimization type table. Although before going to the break, we have learned that particular procedure, but this is a complex problem. So what was the procedure? The procedure was to have the maximization type table converted into a minimization type table. So for that particular conversion, what we need to look for? We need to look for the maximum element in the entire table. So in the entire table, we have this maximum element. No other element is above this element 42. So what is to be done? We need to subtract 42. We need to subtract all the elements from 42. So 42 minus 42, 42 minus 35, 42 minus 28, 42 minus 21. So we'll have the elements and we have to write it here. Then 42 minus 30, 42 minus 25, 42 minus 20, 42 minus 15. We have to write it here. And in the similar grounds, we have these numbers which are written. So this matrix, which was initially a maximization type matrix, it is being converted into a minimization type matrix by doing that particular procedure. Now, what is to be done? We have to adopt that same Hungarian algorithm, and that Hungarian algorithm says that we have to go with the row minimization and then the column minimization. What is row minimization? We have the first row. We have to look for the minimum element in the first row. So minimum element here is 0. So we need to subtract 0 from all the elements. So that remains same. Then we need to look for the next row, and we need to subtract that minimum element from all the elements of the second row. So the minimum here is 12. So we need to subtract 12 from all the elements. So 12 minus 12, 17 minus 12, 22 minus 12, and 27 minus 12. So that is to be subtracted. Similarly for the third, similarly for the fourth. And then what we will do, we'll go with the column minimization. The column minimization part says that we need to subtract the minimum element from the first column. So the minimum element in the first column is 0. So 0 is to be subtracted from all the elements, that remains same. Then again you have to look for the minimum element, which is 4. So you need to subtract 4 from all the elements, you will get these values. Similarly for the third and the fourth. So you will get a reduced matrix, and remember that reduced matrix should be non-negative type, it should be positive type. Then what is to be done with that particular reduced matrix? So we have to follow that Hungarian algorithm, and Hungarian algorithm says that we need to move from top to bottom, and then we will be moving from left to right. So when we move from top to bottom, we have to look for the zeros, and in the first row you can see that there is a single zero, so we need to allocate that particular zero and cross the remaining elements of the particular column. In the next row you have to look for the zero which is already crossed, and in the third row you do not have any zero because the zero is crossed. In the fourth you have 3 zeros, so you need to skip that out. Now in the next particular round you need to move from left to right. So in the first round of moving from left to right, you have the first column. So first column has already the allocation. The second column has a 0, so we need to allocate that particular 0 and cross the remaining elements. In the third you don't have any 0 or you don't have to allocate anything. In the fourth you don't have any allocations. So here the case was to have the allocations 4, but you only allocated the 2 elements. So we have to go with the special procedure, which is a complex case of this assignment problem. So that special procedure is related to iterations. So that special procedure is the ticking procedure. So we need to follow that ticking procedure. Ticking procedure I have already explained in my previous videos, which are available in the playlist of S. Chand Academy with the subject name of Business Mathematics. If you haven't watched that previous part, you can go and visit that particular video. So ticking procedure is that in which you have to tick the unassigned row. So there are 2 unassigned rows that are required to be ticked. If those unassigned rows has a 0, so like if this unassigned row is having a 0 and this unassigned row is having a 0, you need to tick that particular column. Now if that column has any allocations, so this is having an allocation, you need to tick that particular row. Till no more ticking is possible, you have to perform the same. Now the procedure says that you need to make a line or cover all the elements which are having an unticked row and a ticked column. So unticked row and a ticked column needs to be crossed. And then you need to look for the minimum of all the elements from the remaining uncovered elements. So remaining uncovered elements is having a minimum value which is 1. So theta here is 1, and the procedure says that where there are 2 lines matching, you need to add theta, and where there is no line, you need to subtract theta. Like in this case where there are 2 lines are matching, so you need to add theta to it. That means 0 plus 2 plus 1 would be there. And where there is a line above the element, you have to do nothing. When there is no line, that means where it is written 3, so 3 minus 1 is to be done, 6 minus 1, 9 minus 1 is to be done. That means you will perform that iteration like this, and you will form a new matrix. So this new matrix is to be prepared or formed. Now if this matrix is prepared, you have to again go with the Hungarian procedure. So what is that Hungarian procedure? In the first row you have a 0, so you need to allocate that particular 0. If this is done, you need to cross the remaining elements of the particular column. In the second row you have 2 zeros because 1 is crossed, 1 is still there, so you need to skip that particular row. In the C part you are having a 0 and a cross, so you need to skip it also. In the third you are having 3 zeros, so you need to skip it. So top to bottom is done, and when we move from left to right, the first column is allocated already. The second column has 3 zeros, so you need to skip it. The third column has a single 0, so you need to allocate this 0 and cross the remaining elements or the numbers which are zeros in the corresponding row. And then the fourth one cannot be allocated because the 0 is crossed. Then you again move from top to bottom. So now moving from top to bottom, the first row is allocated. The second row now is having 1 0 only because we have again came back to this particular row. So I need to allocate this. Now this one is allocated, and then I need to cross this 0. The third one is not having any 0, not having any allocation. The fourth one is already allocated. So what we have done, we have converted that 2 allocation matrix into a 3 number allocation matrix. Now till now the problem is still not solved, because we have to allocate 4 jobs to the 4 persons, but here you can see that only 3 jobs are allocated. So here what we'll do, we'll again repeat that particular iteration and go with the same procedure, which is the Hungarian method. So what is that ticking procedure? We have to do the same procedure. And what is that procedure? We need to tick an unassigned row. So here this is an assigned row, this is an assigned row, this one is an unassigned row. So we need to tick an unassigned row. If that unassigned row is having any zeros, so we need to tick the particular column. So these 2 columns are to be ticked. Then if these 2 columns are having any assignment, we need to tick the corresponding row. Let's say this column is having assignment, which is this. So we need to tick the corresponding row. This column is again having an assignment, so we need to tick the corresponding row. Now what is to be done? We need to cover all the elements of the unticked rows and the ticked columns, so that all my zeros in the matrix are covered. So this is, with this procedure you can cover all the elements with minimum number of lines. Now you have to look for the elements from the uncovered elements, you have to look for the minimum number. So minimum number here is 1, so theta is 1. And what you need to do with theta, where there are 2 lines matching, you need to add theta, and when there is no line, you need to subtract that theta, so that a new matrix is formed. So while doing that particular stuff, a new matrix is formed like this. When the 2 lines are matching, you need to add theta. Where there is no line, you need to subtract that theta. Now the same procedure, same protocol is to be followed from top to bottom and left to right. From top to bottom, you can see that you are having 1 0. So you need to allocate that particular 0 and cross the remaining elements of the column. In the second, you are having 2 zeros. In the third, you are having 2 zeros. You need to skip it. In the fourth, you are having 2 zeros. So again, skip it. Then you will move from left to right. While moving from left to right, you will have this 1 0 which is already allocated. You will have 2 zeros again, and here you have 3 zeros, so you need to skip the particular column. In the fourth, you have single zeros, so you need to allocate it and cross the remaining. Now you have to move from top to bottom again and left to right. So when you move from top to bottom, you are having 2 zeros again, 2 zeros again, left to right again you have 2 zeros. So for that particular situation, what you will do, you will go with a random manner. Random manner means you can go with allocations with 2 cases. That means it has 2 different solutions. In the first stage, if I choose this 0, let's say in a column, if I choose this 0, so I have to cross this and I have to choose this, I have to cross this. So this would be my first solution. In case of the second particular category, I may choose this 0, and if I choose this 0, I have to cross it. If I choose this 0, I have to cross it. That means I will get 2 particular solutions. For the first case, I have chosen this, and this would be the allocation. For the second case, the allocation would be different, but the total value of the cost would be same in both the 2 situations. That means this problem is particularly the case of solution which is an optimal solution, and that particular solution can be 2. So the total remains same, but the allocations might be different. So while doing that particular allocation, there is no difference with the total value. So total value needs to be maximized. So that was a particular complex problem which was related to the maximization type problem. So with this, we come to the end of the maximization type assignment problem, and particularly wherein we learned 2 different cases. Firstly, we learned about the conversion of maximization type assignment problem into the minimization type, and going with the same protocol in which you may not require any sort of iteration for allocations, but if any particular allocation is not completed, then you go with the iterations to perform that particular allocation. Thank you.
If you want to study this topic in detail, refer to these books from S. Chand Publishing and Vikas Publishing House. Link is provided in the description box. If you found our video interesting, please like, share and subscribe. And do not forget to press the bell icon.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.